Oh, Eliza won 40 lollipops playing basketball. That's a little weird. She gave 2 to every student in her math class, and then she has at least 7 lollipops left. Write an inequality to represent the situation. No. Okay, so it says at least 7 lollipops left. That's where our inequality is actually going to come in, okay? At least or more than, those are words that you're going to use in order to signify that we're going to do an inequality. So we're going to have at least 7. That means 7 is going to be the least amount. Okay? And then she started off with 40 lollipops. Okay, so we're going to give those lollipops right here. 40 lollipops.
40
No, just 40. Okay? And then this little sweetheart gave out 2 to every student in her math class, right? No. So we took 40 and we're going to subtract. How many times does she do that?
We don't know.
Well, we don't know how many kids are in her class, right? So we're going to say X. Okay? So what is X representing?
How many kids are in the class? How many kids?
Okay? On part B, we're going to solve the inequality to find the maximum number of students in her class. So we've got 7 equals 40 minus 2x. Notice how I changed this from an inequality to an equals so that I could solve. So I'm going to subtract 40 from both sides.
Yeah.
And that's going to give me negative 33 equals negative 2x. I'm going to divide by negative 2 on both sides. X is going to be 16.5. But you just brought up a good point. We can't have half a kid. So my thing is, all right, if we round up to 17, this is important. If we round up to 17, let's plug it into our equation. So if I plug 17 into here, I'll get 40 minus 2 times 17, which is 34. So that's 6. Is 6 bigger than 7? No. So that doesn't work, right? So then we've got to round down on this one. Yep. So the way I remember it is if it says maximum number, I'm going to round down. So it says more than 450 students went on a field trip. 10 buses were filled and 5 more students traveled in a car. Write an inequality to represent the situation. Be sure to define your variable. So more than 450 students. That means 450 is the smaller number, right? Okay? And then it says 10 buses were filled. Well, how many kids can fit on a bus? Let's think about it.
Well, really, 12 times 2. Really, if you fit in 3 to a seat, like we didn't do No, wait, it's 24.
Okay, so you got 12 seats on each side, and you got 24 total seats. And so then sometimes the bus driver's like 2 to a seat. You're like, oh my God, that's 48 kids, right? Okay? Or 3 to a seat if you're like a kindergartner or you like this big. Yeah? Okay? So, but we don't know for sure, right? We don't know if we're dealing with high school football players or kindergartners, right? Because it doesn't say that. So we're going to say 10x, okay, plus 5, okay? And x is going to be equal to the number of kiddos that we can fit on a bus.
Oh, I get it. So it's 450 equal.
Let me live my life. Okay, so then it says solve the inequality to find the minimum number of people on each bus. Okay, so we're going to take 450. Oh, wow. What is this handwriting? 450 equals 10x plus 5. I'm going to subtract 5 from both sides. Okay. We're going to divide by 10 on both sides. And x is going to equal 44.5. Now, here's the deal. I can't have half a kiddo. That would be really sad.
You round up, so it's 45.
So, if I round up to 45, if I plug 45 in here, that's going to set me equal to it, right? Right here?
Yeah.
Okay? But if I round down to 44, that's only going to get me to 445. So that doesn't work. So we're going to have to round up on this one. So if it's minimum, we go round up.
So basically the opposite.